Alrighty everybody, here we go with the beginnings of balancing redox reactions. You may or may not remember doing this at all from Chem 1. If you were in honors, some of your teachers probably did it and some of you didn't. If you were in regular, you've never seen this before in your life. So just listen carefully, watch it a couple of times, and see if you can kind of put together some patterns. Balancing redox equations takes a lot more effort than just balancing the atoms using, number of atoms on each side. You also have to balance the charge. So to recognize, the first thing you have to do is be able to recognize that a redox reaction is even happening. And to do that, you compare oxidation numbers. So that's what we did in previous steps. The second step is to break it into a half reaction. So that means whatever's being oxidized, that's one half reaction, and whatever's being reduced is the other half reaction. The next thing is to balance the overall mass. So these are the things like chlorine or bromine or sodium, things that are regular old atoms that are easily balanced by mass. And then after that we have to balance the H's and the O's. And the reason that we have to leave these separate is because this is where we get all of what appear to be missing pieces. This is where we take care of them. And depending on whether it's acidic or basic solution depends how we operate the hydrogens and the oxygens. If it's an acidic solution, you first balance the oxygens by adding water, and then you add H pluses or hydrogen ions to the opposing side. In a basic solution, however, you have, for each oxygen that is needed, you add 2 hydroxide ions for each oxygen that's deficient. And the reason that you have to add 2 hydroxides rather than the one that you expect is because you still have to use water to balance it on the other side, and each water contains 2 hydrogens, so that gives you an inappropriate ratio. Whereas if you just double the amount of oxygen that you need to begin with, balancing it with the water is a lot easier. Finally, balance the charge with electrons. If the number of electrons in each half reaction are not the same, then you have to multiply them until you get the same number of electrons on opposing sides, and then add them up. I made a note down here about starting to memorize stuff on page 68 of your Ultimate Equations Handbook. Just look at it for now. This will not really be required actually until the spring, but be aware that in the Ultimate Equations Handbook, you may or may not always be given the products of one of these. For this particular unit, for unit 3, sorry, you will be given the products, but eventually you'll have to learn to do them. Alright, so back to our process here. At exercise 12, the first reaction is very simple and very straightforward. It is just a straight single replacement reaction. So you have silver nitrate and you have copper, and then you have copper nitrate and silver. So we're being shown that we have a single replacement reaction. There's really, this one you can just balance by inspection or just balance with the elements, but just to kind of show you the process overall, a half reaction is really just the pertinent parts of the equation. So we can see that silver changes its oxidation number. So silver plus 1 on one side becomes silver on the other. Copper on one side becomes copper plus 2 on the other. In order to balance the next step, we don't really have to do anything with hydrogen or oxygen because the only oxygen we have is nitrate and there is no hydrogen. So in order to do this next step, we just need to balance the electrons. And to do that, we have a +1 charge on the reactant side for silver and a 0 charge on the product side. So we need to add 1 electron to the reactant side for silver. For copper, we need to add 2 electrons to the product side over here because the neutral side is 0, the product side has to be 0 as well. You can see here that 1 electron in the reactants and 2 electrons in the products doesn't work. So this is what we're talking about when we say multiply them. You have to multiply the whole thing. And then this would now look like 2 electrons plus 2 silver ions yields 2 silver atoms. Now that you have an equal number of electrons in the reactants and in the products, they can be canceled out, and you can put the equation back together, and you get copper plus 2Ag plus yields copper plus 2 plus 2Ag. And that becomes your balanced net ionic equation. Again, we could leave the nitrate